All right, everybody, welcome back to another wonderful math lesson from me, your buddy, Mr. Oldenburg. I have no stylus today. I forgot it. I'm trying to record this in the library. Simple lesson, hopefully short. This whole unit is going to be about memorization, guys. We're going to do all these geometric properties about triangles and quadrilaterals, and it's all going to come down to, are you studying your properties? That's it. There's not much I can really teach you because it's all about identifying stuff. So you got to put in the time, the effort, look over those properties, look over the different shapes, pick them out, things like that. Those note cards I gave you, the purple cards, are the best friends of yours for the next week. So let's start classifying. Here's some definitions. First, let's take a look at some triangles. We have an equilateral triangle, which is equal on all sides. So every side will be the same. Oh, before I get too into this, we classify triangles two ways, by their angle and by their side. And really, the first thing we do is we should be classifying it by its angles, because triangles have a first and last name. Kind of like mine's Ron and Oldenburg. A triangle would have an angle name and then a side name. So let's look at the angles first, since that should really be their first name. In order to identify a triangle by its name, you have to look at its angle measure. There's three angle measures you need to know. A right angle, acute angle, oh, it's totes adorbs, and an obtuse angle. All right? Everything revolves around the right angle. A right angle is 90 degrees, and it's usually represented with a little square in the bottom saying it's square. Square means 90 degrees. That was a big jeez. So, it's not always there. Sometimes they want you to assume it. When I went to school, it was, if that little box isn't there, do not assume it's 90 degrees. Apparently in 5th grade for the last 10 years, if it's not there and it looks 90, it's 90. All right, so a 90-degree angle. Shazam. Now, let's take a look at an acute angle. And an acute angle, totes adorbs, also revolves around 90 degrees, because everything revolves around 90 degrees. I'll tell you why in a second. So an acute angle has three angle measures that are all less than 90 degrees. Boop. I want my stylus back. That's terrible. I'll write that again for you. So 90 degrees is greater than all these other angles. They're all small. They're all pitched in. They make little alligator mouths. Yay, alligators, because it's green. It's going to be all acute, all right? It's not just two, because if you get two acute angles, if you look back at the right angle for a sec, oh, this is going to get annoying. I wish I had like the smartboard software that I could just do the circle and erase it all, because I'm writing all over this junk. This video is going to be so much longer because of all the extra jargon. All right. So the right angle, if you notice, has two acute angles and a right angle. I'm going to tell you why in a sec. Hey, he said that a sec ago. I know. So, an obtuse angle has one obtuse angle. That angle is greater than 90 degrees. And then there are two acute angles. There'll always be at least two acute angles, guys. Reason being, well, you need to know that every triangle, no matter what triangle it is, has 180 degrees worth of angles in it. No matter what, every triangle you have, if you add up all of the angles, it will always equal 180. Now, that's important because triangles have three vertices, 3 points where they meet, right? If I tried, and this is a question later on in the book, but I'll explain it now because we're talking about it. If I tried to draw a triangle with a right angle, here's one, and I try to do another one with a right angle, well, I already have 1, 2, 3 lines. I can't draw any more lines and have a triangle, can I? No. Reason being is I already have 180 degrees worth of angles. I can't make another angle because 90 plus 90 is 180. There's no way I can close that figure. Same thing if I had an obtuse angle. If I had an obtuse angle, okay, and this is, say, 130, I only have 50 left. If I don't make two acute angles, it's not going to work. So if I go to make another obtuse angle, there you go. So let's say that, let's go 130. Why not, right? Because we're on our way to make a trapezoid. Take a look. 1, 2, 3. There's no way I can close it. So the big lesson here, aside from acute angles, you will never have more than one of the other type. So there will always be one right angle and two acute, one obtuse and two acute, or three acute angles. So cute. Totes. Boom. All right, now let's talk about the sides, because the sides matter too. So here, an equilateral triangle has three equal sides. It's a flux capacitor. 10 points to whoever remembers where that came from. We have isosceles triangles. Isosceles triangles have two equal sides. And finally, a scalene, where there are no equal sides. Everything's different. So, all, some, or none. You just got to memorize which one's which. And now we're going to start putting them together. So, I just spoke about number one a second ago. I'm not going to go over that, but they wanted to know about the a right triangle having an obtuse angle, and we talked about why I couldn't, because it's going to be over 180 degrees. Number two, can an equilateral triangle have only two sides of equal length? Why or why not? Of course not. We just learned that by definition, an equilateral triangle has all equal sides. If it's all equal sides, that doesn't mean two, it means three. Let's talk about how to classify, because here's the steak and potatoes of this lesson, kids. So they give me two different triangles. Let's look at number 3 first. Like I said, every triangle has two names, a first name and a last name, an angle and a side name. First thing I notice, all three of my angles are the same. They are all less than 90 degrees. Any angle that is less than 90 degrees is called acute. Now, I didn't just go and name them right away. I didn't go acute. I thought about why they're acute. A lot of times you're going to have to do reasoning when you classify these. You're going to resort to the definition. You can't just look at it and be like, yeah, acute. Yes, you'll get to that when you're older, but for right now, you have to understand why it's acute. So always say the definition. I don't have any angles that are 90 degrees or greater, so they're all acute. Then I look at my sides. Mashed potatoes, mac and cheese, and broccoli. Or 3, 3, and 3. So I should have really said that they were all the same, but I didn't. Now they all have equal values. That is an equilateral. And what shape is this? This is a triangle. And that's how we name it. First name, last name, name of the shape. Or first name, middle name, last name, however you want to do it. Thing is, it's always got to be the angle first, then the side, then the shape. And always identify the properties. So, looking over here, my angles. The first thing I notice, I have a 90-degree angle here. If I have a 90-degree angle, that's a right angle. So this is going to be a right triangle. What kind of right triangle? I don't know. Let's find out. I have a 7. I have a 7 on the side, and I have one that's different. So two sides are equal. That, by definition, is an isosceles. And there are 3 sides to this polygon. Just spell it out of order. Oh, jeez. There you go. There are 3 sides to the polygon, so it's a triangle. All right, a couple more and we're good. First, my angle measures 75, 75, 30. None of those are 90 or above, so this is an acute. So cute, so cute. I have a 6, and a 3. These two are the same. 2 equal sides are isosceles. Triangle. Number 6, I have a 90-degree angle. This is a right something. 9, 12, 15, they are all different. Scalene triangle. This goes really quick once you know the definitions, guys. Number, well, whatever, 7, 60, 60, 60. None of those are above 90. This is an acute. And notice they're all the same. When they're all the same, and by the way, whenever you have an equilateral triangle, you'll always have 60, 60, 60 in the middle. All the sides are the same, 11 centimeters. This is an acute equilateral triangle. Number 8 has 110 degrees. That is greater than 90 degrees, so it's obtuse. 9, 15, 9, 9 2/10, 9 and 2/10. Those are identical. So it is an isosceles triangle, an obtuse isosceles triangle. Down here, we have a right angle. 6, 8, 10. I reverse those, but they're all different. So it's scalene triangle. And finally, none of these look like a 90-degree angle. They all look less. So it's acute. 12, 12, and 6. 2 of them are the same. It's an isosceles triangle. And that's all we got today, guys. Memorize, memorize, memorize the properties. Look at pictures. Play with them. Identify them. Look at the cards. Look at the picture. Do whatever you need to do. You need to know the properties. You need to know what it's like. There's no more I can really do than that for this lesson. Sorry, guys. But I hope you enjoyed this one, and I hope it helped. Take it easy.